Welcome to Do-It-Yourself Mechanic. The purpose of this video is to discuss a case study where I helped a friend with a Civic that had a surging issue when the car was warm and it would crank no start when the engine was warm as well. So let's navigate to case studies. Civic surging and no start. So a friend called me and said his 99 Civic was surging when it was at operating temperature, and it would not start when the engine was warm. It would crank, but would not start when the engine was warm. If the engine was cold or intermediate temperature, it would just fire right up and drive pretty good. But when the engine was warm, it would surge and it would not start. You know, on first appearance, many people are probably thinking, IAC, slam dunk. Well, maybe that's not what it is. Let's keep reading and see what I found out in this case. So before I begin, you sort of need to know a history of this car because it all sort of makes sense. About 3.5 weeks before this call, I worked with my friend and we changed the timing belt, water pump, and valve cover gasket. I used a tool named Airlift to refill the cooling system. Again, I'm not being paid for Airlift. I just like the tool. You can watch more about it with the link at the bottom here. Vortec Make You Loco has a really good demonstration how to use it, and Matco Tools has a similar tool, and you can see how it works. They have a nice little setup and shows you. At a high level, what it does is you hook it up when your cooling system is completely empty, meaning your radiator is empty. Of course, your block is never empty, right? There's always passages. Anyway, and this tool uses shop air, uses a Venturi action effect to pull a vacuum on your cooling system to about 25 inches of mercury. You then, go through, you'll see it in the videos, you then can actually suck in coolant into your system. Why would you do this? Why not just pour it? Well, what it does is it tends to reduce the probability of you getting an air pocket, and Hondas are known for that, so I brought my tool out. Well, the reason I'm even talking about this tool is that about a week later after the installation, everything was working great. A week later, my friend calls me and says his heater stopped working, and he was sort of thinking that the Airlift tool broke his heater core, and I didn't think that was the case. I suggested that he disconnect both ends of the heater core. Remember, there's an input and an out from the cooling system that goes through your heater core. And I suggested he disconnect it and flush it. But unfortunately, he didn't quite do it the way I suggested. He disconnected one end of the heater core. I'm going to guess the top half, so all the coolant wouldn't dump out. And then it appears he was cleaning his IAC, and in many cars the IAC, idle air control valve, also has coolant in it, so it warms up the the air and the whole device itself, the whole actuator, because it can get cold because it's getting ambient air from the outside. So on cooler temperatures, it uses the coolant to warm it up so it functions properly. Well, it looks like he had the IAC off, and when he lightly blew into the heater cord, blew out a whole bunch of junk into the IAC out, the IAC passage is on top of the motor. And if you think about it, that's sort of dangerous, right? Because when you're accessing your IAC, you probably have your throttle body sitting right there, and he could have, it looked like he didn't, could have dumped a fair amount of coolant into the intake, and we all know liquid does not compress, and you can toast the motor. But again, that did not happen. I'm just saying that so people know why you need to be careful with allowing too much water into your intake. Anyway, so that fixed the heater. He connected it all back up, and the heater worked. He was happy. But I'm guessing when he did that, his check engine light came on. I'm guessing. So let's begin our study. So that's the history. So my friend calls me, tells me his check engine light is on, and he tells me what I just described to you. He then told me that when the car is warm, it surges at idle, and it won't start. It cranks and won't start when the engine's warm. So what he would do is he was coming home from work one time, and he had to do some honeydews, stopped at a store, bought some milk, let's say, went back in his car, wouldn't start. So he just waited there. He didn't call me at that point, and he just waited. And he said he just waited long enough, tried it and started, and he came home. And he started looking on the internet and diagnosing it from his vantage point. And he thought for sure it was bad IAC. I would agree it could be, but I'd want to run more tests. So the backstory before he called me is that he watched several YouTube videos about how to clean an IAC for his make model Honda. He removed it, cleaned it, and reinstalled it. I'm guessing he did it, like I said above, at the same time he was flushing out his heater core. But the surging and no start condition did not clear up. Again, the heater core issue was fixed, meaning it got hot inside now, meaning coolant was able to go through the heater core. If you guys remember, the heater core is very much like a miniature little radiator that's inside your driving compartment area, and air, coolant is brought through that, and a blower blows through that and warms up the air inside the cabin. But the main problem now is the car won't start, it surges, and it has a check engine light. So he called me and described that, and I think when I look back, the reason he called me was for me to read his check engine light. I think he was pretty confident it was the IAC, it was going to give an IAC error, and I was even sort of biased that I thought it was IAC, but I wanted to prove it, so I was happy he asked me to come over. So I pulled the code. It was P0113, and when I first read it, I thought it said IAC, not IAT. But I did the next step in troubleshooting as I researched it. So on my scan tool, I entered in. This is what was displayed. So my eye thought I saw IAC. And then when I typed in the code, this is what it gave me, and it said intake air temperature. I'm like, whoa, please make sure to watch what you're doing. Don't presume, don't assume. Look at the data, let the data talk with you. And what it is the sensor, the computer sense circuit is reading a high voltage. So that could be caused by an open in the IAT circuit, which means perhaps the pins in the connector aren't touching. The voltage sense wire is open, or the sensor inside itself has an open. So again, this is a thermistor, so that's why you know it's at least one of those three conditions. So then I proceeded to the next step as I did a visual, and we looked in the shop manual where the IAT sensor was. I didn't know, and it was right on top of the throttle body, which makes sense. And it looked great. It was probably one of the cleanest sensors in his old car. It was almost as if it was replaced, but it wasn't. The wire looked good. The connector was solid. I was like, wow, okay. So then I hooked up my scan tool and was viewing the IAT PID. It was perfect. I used my infrared temperature scanner hit the IAT sensor portion, and it read ambient temperature, and it matched within 5 degrees of what the PCM was indicating, what was showing on the scan tool. So I was like, I then wiggled the connector. It didn't change. I then wiggled the wire, the sensor wire, as much as I could, touch it till it went into the harness. It was fine. I was like, well, maybe when it gets warm, it starts acting up. So we ran the car, came to operating temperature, still right on the temperature, warmed up exactly stair-step fashion. I'm like, So I lightly smacked it. Sometimes, an internal issue in the sensor will be loose when it's warmed up. Still okay. Again, I didn't hit it hard. I then wiggle tested. All I did again, the connector all the way down. Solid. I was like, Then it dawned on me, because I was looking at it and I saw the IAC below it. I asked my friend, I said, did you have to remove this whole intake apparatus when you were changing and cleaning the IAC, or cleaning the IAC? He said, oh yeah. I then asked him, I go, would it have been possible that you turned the car on, turned the key to on, when the IAT, the temperature sensor, was not plugged in? It was a long, uncomfortable silence. It seemed like 5 minutes. It was probably 10 seconds or 5 seconds. And he goes, yep, that was it. So the good thing is we resolved the IAT issue. The bad thing is that wasn't the reason for the surging. So I started with a clean slate, no check engine codes or anything. So the first thing I asked, I go, okay, well, is there a way you can reproduce the air and put it in a hard fault state? He goes, sure. So we drove around. We did stop and go traffic and highway. And within 10 minutes, 15 minutes or so, he got it. It started surging at idle. And while we were driving, I had the scan tool set up, and I was looking at it. And I noticed when the car was running with no issues, the IAC was at 15 degrees. And I'm used to Fords. They're usually about 40. Not 15 degrees. Excuse me. Correction. 15%. I'm used to Fords. They're around 40% at idle. But this is a Honda, and I didn't want to condemn it. It was running perfect. So I go, well, this must be the normal setting. I couldn't verify that. I think I did later on in the component test area, and it was about right, 10 to 15%. But when the car was surging, it was moving up and down around the 40% value. So one had to guess, was the IAC stuck closed and the PCM is trying to open it, or was something telling the PCM to open it that far? So I went with the simple one first and thought maybe the IAC was stuck. So I got a screwdriver handle, and while it was in this surging condition, meaning the PCM was trying to open it, I just lightly smacked on it. You don't want to smack on it real hard because there's a permanent magnet in it. But if it's stuck, it'll all of a sudden change. I've done this before. So not hard. You just boom, a nice, light, slight, medium hit. Not very hard. And I hit all around it. It didn't change. I was like, well, maybe it's not stuck. What's next? There must be something that the PCM is being told to make it do that. Well, that was my assumption. I looked all around. And then all of a sudden, I saw it. I saw the ECT, engine coolant temperature sensor, varying a lot. It was almost varying like a O2 sensor. You can't read this top one, but this highlighted one is the ECT. There it goes. And if you notice, it says 62 degrees. The engine is very warm. It should at least read 180. I'm guessing 200 degrees. We are driving. And in addition, look at that signal. It's not flat. Well, look at the IAT. See how it's very stair-step? Yeah, there's a little there. Not sure why. But it's pretty much stair-step. But look at the ECT. It was all over the place. And I watched the ECT as it changed. So did the IAC. Of course, the IAC showed up more than the ECT, because remember, it had to range up all the way up to 200 degrees, because it did get up to there and then it got in this weird state. But they seem to go together. There was a correlation. So we then drove home. And we were in his garage and it was still running. And I decided to, it was surging in his garage, disconnected the ECT, idle, flattened out. Couldn't believe it. Plugged it back in, started surging. Just to be thorough, I unplugged it, flattened out. I go, has to be the ECT. But what's wrong with the ECT now? So then I performed some sensor tests. I back probed it, and the voltage was varying, but yet it was matching what was on the scan tool. So at that point, I pretty much knew it was a sensor, but wanted to be thorough. So I then turned off the car, key on, engine off. That's what KOEO means. And on the harness side, I tested the ground to ground with my scope meter, and it was less than 200 millivolts, so I knew it was okay. I then touched the sense circuit, voltage sense, and it was around very close to 5 volts. I then took a test light, put to ground, and then I touched the voltage sense, and it dropped on the scan tool to 0. So now I knew both wires, there's 2 wires to this sensor, ground and voltage sense, were good. The voltage drop on the ground was good, and the voltage sense was reading a change. So I knew the wire integrity was good. So at this point, I knew the ECT sensor was faulty. I guess the key to this is once we were able to reproduce it, all of what I discussed took about 10 minutes. My friend was blown away because he really assumed it was the IAC. He actually had an IAC on order. And he could not believe that the little old ECT sensor could cause such a drivability issue with the car. But it wasn't behaving well, so that's why the PCM was just acting strangely and causing the idle air control IAC actuator just to move all over the place and be open too much and close and open and close, causing the surging. My friend the next day ordered an ECT, installed it, and the car was fixed. What went well? I stuck to the diagnosing fundamentals and helped me catch a mistake, because remember I just kept assuming it was IAC, and even though the error said IAT clearly, you saw it, my mind's eye saw IAC. But when I went to the next step, the troubleshooter, how to test it, it clearly told me it's IAT temperature. That was early on. And once my friend was able to get it in hard fault, it took me about 10 minutes to diagnose root cause. What could have gone better is that I should have looked at the freeze frame data when I saw the IAT, and I would have noticed that the engine wasn't running, and I would have known maybe he was cleaning the engine or something when that occurred. Thank you for watching. I hope you found the information helpful.